welcome to Hence the Future podcast. I'm Mattimore Cronin,
And I'm Drew Schaller.
and today we're discussing the future of materials science. So, for our listeners, Drew is a materials scientist, and he's also a surfing buddy of mine. So, we've been on some
Hey,
trips together in Mexico, Carlsbad, and I really am glad that I met you and delved into the world of materials science because it was really nothing I had considered before. I've never had really considered what materials are made of or their qualities. But it's kind of similar to emergence, is what I've noticed,
yeah,
is that as you go from these layers of, subatomic, atomic, and then into the macro world, you have different properties at all of these different layers. So I think a good place to start would be to define material science and what it is a material scientist does. Like to me, it
yeah,
seems sort of almost like practical physics, like understanding the nature of materials and particles and molecules with a very practical eye towards how you can actually use them in human life and to solve human problems.
yeah. I think material science is kind of a combination of things that we already know, like chemistry, engineering, and physics. What a material scientist actually does is they look at, the subatomic level or what the atoms are doing, in a material, like localized, right? And how that kind of, embodies in the actual performance of the material.
Yeah, it's just incredible to me that everything is made out of atoms. So whether you're
Yeah,
talking about like, a human baby, a slab of concrete, a tab of LSD, like whatever it is, it's all just made of atoms arranged in different ways, and yet it can
yeah.
have such vastly different properties. So is that what got you initially passionate about material science? Like what initially sparked your intrigue?
So what sparked my intrigue was I think it was in 10th grade. I was in AP chemistry, and we were talking about carpets and how carpets were manufactured, like out of polyester. And it just, lit my imagination on fire of what you can do with simple chemical reactions and synthesis. And, that everything is pretty much made out of carbon in different, forms and patterns. And then, just went on from there.
That's awesome. Yeah, carbon is incredible. It's like so much of Earth, like every life form on Earth is made out of carbon, which is the same thing that diamonds are made of, which is the same thing that
Sure.
coal and graphene is made of, and it's
Which makes it
incredible
seem
that,
kind of silly, right?
right? Yeah, it's like honestly, when I think about material science, it feels a lot like a video game, like Animal
Yeah.
Crossing or StarCraft or something like that, where you start on level one, where you just have some stick that is you use as a fishing pole that's going to break really easily, and then over
Yeah.
time you have better and better materials. And where we're living today, it very much feels like pretty far future, but like from the perspective of our ancestors, but from the perspective of what's possible, it also seems like we're at the very beginning.
Over like 300,000 years, right? We've been developing these materials from, the Stone Age. We're using sticks and stones and feathers and animal skins. And then we're getting into actual like metallurgy, in the Bronze Age, adding copper and arsenic. And then we're starting to work with iron and, porcelains and different ceramics. And then, you come to like modern day, you're using oils and plastics. And then, you progress to electronics and you have to really use like silicones. And, we're constantly progressing with the materials and we're almost dependent on it.
Yeah, totally. And it's interesting to consider what makes something a good material because there are so many different lenses you can have of how you measure whether it's good or not. You can measure how effective it is, but also how readily available and inexpensive is it? How much can it withstand certain stresses? But also what sort of emotional effect does it have on us? So
That's
there are
true.
so many different filters. Maybe we can go through a few of the filters. So let's take what filter of a warrior. Like walk me through a warrior who starts as like a caveman with like a stone spear to then someone who has like a bronze sword and then like an iron sword and then like a steel sword. Like why is it really that much of an advantage for a strong warrior to have a high quality steel sword like Excalibur against like enemies with just
With a
iron
stick.
swords? Yeah, or
or stick
stones.
rather.
Right.
I think as you start experimenting in some of the metal alloys, your materials get stronger, and we classify things on different filters, right? With strength, flexibility, and it kind of impacts the way that you would fight, right? If
Hmm.
your sword was bulky and heavy and was brittle, that probably wouldn't be a good case. Like if you hit it on their armor that was stronger than the sword, it could break, or
Right.
you know, it could bend, right? And then it wouldn't be such a good prodding device.
Yeah,
um,
I was reading this archaeological research paper, and they were talking about how this Roman legion, when they abandoned their fort because the barbarians were invading them, they actually buried all of their iron.
Weapons.
No, not the weapons. They brought the weapons with them, but they buried all of the little like screws and nails that they would use to set
Mm,
up their fort because it was so valuable. Like that was what had
just
allowed.
technology.
Yeah, yeah, and like all the Romans would go around with their little like razor, which differentiated them from the barbarians because it was like this nice
Ah,
steel razor, like a true sign of civilized life.
hmm,
Um,
interesting.
but okay, so that brings us through like the sword weapon sort of age of weaponry. Like what I guess like I'm trying to think about as far as weapons in like modern time and into the future from the perspective of warriors, like what would the ideal weapon be now based on just a material basis, and then what could be possible in the future? And then we can look at other lenses.
I guess if you look at it in just minimal forms of just weapons, it's kind of the same way, like stronger materials, lighter materials. But what changed the game, I think, was Galileo with the telescope, right?
Mm,
He was able to spot, armies from afar, and that gave you a tactical advantage, right?
right.
So that was a major improvement in warfare.
Yeah,
So you get getting into optics and lensing. So that's really the quantum leap in technology.
right. Yeah, I've read that that was one of the big advantages the West had over the East because we adopted glass really early on because,
Mm,
the Romans really valued a nice glass drinking vessel where not only can you taste the wine and smell it, you can also see the beautiful red color. And so it became this symbol of civilized life, even though it wasn't the most practical material for drinking out of something because it breaks. And
yeah.
because of that, it led to the telescope, the microscope, and those inventions didn't occur in the East for a very long time because it just wasn't part of their culture. They drank out of porcelain and other types
Hmm.
of drinking instruments. So, yeah, I think that's interesting. So that's one filter, which is sort of the filter of the warrior. Another interesting filter is like the environmentalist filter because you could think of, originally we were using all biomaterials, like, we'd use wood and stone and all stuff that just gets
Ceramics.
recycled. Yeah, it gets recycled into the earth, clay. But now we have a lot of materials like plastics that take a really long time to return to the earth. And we are making some progress on this. It looks like we may be developing some plastics that are biodegradable. So, in your mind, is plastic something that most people misunderstand? Like, how would you respond to someone who says, God, I just hate plastic and concrete. If we can get rid of all plastic and concrete, we'll be better off.
Well, I think that's easy to say, from an outside perspective, but plastics kind of revolutionized the way that we lived, and they save a lot of lives with like catheters and simple medical devices. Even drinking water, right? It makes it more accessible, and we really didn't understand the implications of producing so much plastic until recently. We see the pollution, and they don't degrade at least the way that we would like them to, which is fast and readily. And if we just bury it in the ground, hopefully, it'll just disappear, right, and disintegrate.
Hmm.
Um, yeah, lately I think we have made some strides in some bio-based plastics and biodegradable plastics, right? You got to differentiate the two. You can have plastics whose raw materials come from corn or some other bio-based element,
Like seaweed.
and then you could have, yeah, exactly, like different types of natural polymers. And then you could have, some plastics that actually degrade when they're composted, or if they're left to oxygen and UV radiation, right? So I would say that there is a lot to be done in terms of improvement to our outlook on plastics, but I think they'll still be around
Hmm.
for the long term because they're so useful and we love their properties.
Yeah.
If you had a carton of milk, right, and you put it on the shelf for a month, and then it has started degrading, and then it fell apart, that wouldn't be desirable. But we kind of like it that it can be there for a year, right?
Right. Yeah, because of entropy, everything eventually degrades, just a matter of how
Right.
long, which kind of makes me feel even more like it's a video game. Like everything eventually goes back to level one, and you just try to beat the game
Yeah.
as quickly as you can. Um,
That's an interesting outlook on it. Yeah.
yeah. So, okay, that's the environmentalist angle, and I agree with you. It's not like we should abandon any of these materials. It's more that we need to innovate and find ways of discovering new variations of materials, or even, creating in a sense. I don't know if you have an opinion on whether materials are created or discovered. It's kind of a philosophical question.
I think with plastics, they are more created, right?
Right.
You have to actually add two things together, polymerize them. So in that sense, I think they are created by mankind. I don't think we will find them anywhere else.
Right. And you work with polymers specifically at your job, is
Yeah.
that right? So what do you
Yes.
like I'm curious what you do in like a typical day of work. What's your day-to-day work look like?
So, do you have a firm grasp on what like a polymer is?
No, I'd love for you to explain it.
So, a polymer is a macromolecule that's made up of repeating subunits. Like polymer, mer is like one individual unit.
Hmm.
We could look at polyethylene or polypropylene, for instance, which is just a couple carbons in a chain, right? And then that is repeated many times over. It could be 1,000 times, 5,000 times, 10,000 times, and however long the macromolecule is, it changes its properties, right? And you could actually have many of these long chains that are cross-linked together, right? And it makes
Hmm.
it more rigid or more flexible depending on your cross linkage. What I work in specifically is hydrogels. So you have a cross-linked network of all these polymer chains, and they're able to absorb water, and that makes them inherently conductive. So you could dissipate a charge to the skin, right? And that's what neurostimulation is. Um, Also, you could load the hydrogel with a conductive uh, drug like lidocaine, and you could push it through with a direct current, which is what ionophoresis is.
Huh.
So we
So
can do that as well.
so are you spending time actually creating these polymers, or are you analyzing different polymers to see what their properties are? I mean, you're
So
probably doing a
both,
lot of
yeah,
everything, right?
yeah. No, I go to the formulation table. I come up with a gel, synthesize it, and then I use rheology, which is basically looking at the deformation of the material to determine how stiff it is or how its atoms flow in the gel matrix.
Hmm, interesting. Yeah, I was reading about this material that NASA is using called aerogels.
Oh,
Have you
aerogels.
ever
Yes,
actually
I'm
held one of
familiar.
thit's things? It looks like something out of this world.
Well, so no, I haven't. I think I could make one if I was given the right instruments. So it's basically just like a hydrogel, and you super critically dry it. So have you ever seen a phase diagram?
Yeah, yeah,
How you have solid, liquid, and gas, and
right.
there's a critical point where they go off in different directions.
Oh, I see.
So instead of going from liquid to gas or liquid to solid, you increase the pressure and increase the temperature of the gel, and it kind of dissipates the liquid and it turns into a gas, but it doesn't damage the structure of the polymer. So it turns into this like almost like polystyrene, like a foam or something.
Right,
And
and it can
super,
withstand like tons of impact, right? That's the basic idea. It's like
yeah,
that science experiment where you try to drop an egg off of the second floor science building, And if you have some aerogels, you're definitely going to win the class
Yeah,
prize.
definitely. You're going to win the class prize. Everybody's going to be super amazed because it really hasn't been around for that long, you know.
Yeah. Well,
But yeah, there
so
has been some research suggesting that you could use that for aerospace coming into the planet's atmosphere. Right, it gets really hot, so maybe that
right.
could
Yeah, I
cushion the
heard they
blow a little.
used it in one experiment to basically capture space dust so they could analyze it. And normally, you've got this dust like hurling through space at these incredible speeds. So you can't really catch dust. Either you have something that's like, Kevlar that's strong enough that it'll just basically destroy the dust when the dust hits it, or you have something that's not strong enough and the dust will just go right through it. So aerogel is special in that you can actually like withstand the impact and cushion it because there's all of these different layers of like gaseous bubbles that take in the impact. um, but I love how you were explaining sort of what's happening on almost like a geometric level and micro level for these compounds, because one thing I wasn't really aware of before I started researching this is that what makes a material strong is almost this phenomenon of Russian dolls where there's like little atoms inside of other atoms that fit together just perfectly, so it's super strong, and then they fit into a bigger structure that's like
Yeah,
super strong. And you're creating these like real, like graphene, for instance. It has that hexagonal shape that just looks sturdy, it feels sturdy. We use that kind of structure in the macro world. So what can you say
yeah,
about like the structures and what that can tell us about the nature of materials?
yeah. So crystallinity, we look at that when we're looking at different crystalline polymers, and that's the like repeated unit cell. Like if you look at it atomic level, and if it's completely symmetric, you could determine certain characteristics about it. If it's asymmetric, like in piezoelectric materials like quartz,
Hmm.
if you squeeze them or expand them, that creates a voltage because of the dipole of positive and negative electron flow. And you could, you know, if you multiply that from unit cell to unit cell to unit cell to unit cell all throughout the crystal, it creates a measurable voltage.
Hmm.
So that's something that I don't know if that answers your question at all, but that's
Yeah,
one
no,
thing.
I understand. It's like I've seen that, graphene, a visual of it is like it's literally one atom thick, and you have this
Yeah,
hexagonal shape that sort of, spreads out in this same sort of pattern. Whereas a diamond is the same carbon atoms, but instead of them being one atom thick sheet, it's like this like it's kind of like a diamond shape. It's like it has a height and a width and a depth. And
for sure, it's three dimensional. So
right,
like what
right.
graphene is actually like a two-dimensional, one atom thick layer of carbon, and it's polycyclic and it's aromatic. So aromatic versus aliphatic is that an aromatic compound forms like a ring, versus like a hydrocarbon, like gasoline or something, which is just a long chain of carbons,
Hmm.
right? But what makes graphene so special is that it's covalently bonded to three carbons around it, which makes it super strong, and it has
Hmm.
delocalized electrons so that it's super conductive, and it's over one atom layer, so it goes really fast through the actual material. Um,
Yeah,
so
I
yeah, if
was
you want to talk
amazed
about graphene,
to hear that it was 200 times stronger than steel, and
yes,
it's
yeah,
one atom thick. So you could have
one
like
atom.
bulletproof underwear.
Yeah, yeah, I guess you could. Yeah, bulletproof clothing, and it's also super conductive. It's at one atom thick. It's transparent. It's also one of the most impermeable materials that we have ever discovered. And actually, the story of how it was discovered is kind of,
Yeah, let's
funny
hear
as
it.
well. Yeah, so you would think that with such this compound with all these incredible features that it had to be synthesized in so many steps, and it's like very complicated. But actually, two researchers at Manchester University in 2004, I believe, they were physics professors, I think, or graduate students. Either way, they would get together on Fridays and tackle some problems that weren't in their discipline. And so graphene was already. Oh, sorry, that's the train. Um, Graphene was theorized before, and so they decided, you know what, let's give it a shot. And they took a graphite puck and they took a piece of Scotch tape and they put it on it and removed like probably 100 or 200 layers of what was graphene, and then they folded it over, did it again, probably removed 50 layers of graphene, put another piece of tape on it, removed it, 25, and so on and so forth. And they got down to, like something they couldn't see, and then they dissolved away the tape, and then that's how they isolated
Wow. That's like
graphene.
something you could do at home. You just get a little number
Yeah.
two pencil, some Scotch tape.
Yep. That's
That's
exactly how
amazing. And
you can do it at home.
and this is something else that I'm so amazed by is that up until now, or very recently, all materials discovered have been pretty much by chance or just by trial and error, like just trying different concoctions of copper and tin to find the right sort of bronze, different concoctions of or different ways of treating carbon to get different properties out of it. So there's this new field called material informatics, and you sent me that video about it. So maybe you
Yeah.
can say a little bit about how we used to discover new materials and what in the future will be the process for discovering new materials.
Yeah. So what I do at work and what pretty much all material scientists do is that you mix some stuff together and you make the material and then you test it. And if you have high throughput testing, that's even better because you can get, many tests and um, a degree of accuracy that you would want. But this is painstaking and it takes a long time. I mean, if you think about, Thomas Edison with the light bulb, he went through like a 2-year trial of just using every filament he could
Mm.
think of. And then he finally comes up with one, the bamboo. I think it was a carbonized bamboo or filament. And, it lasted 1,200 hours. So it's genius, but it takes a long time and we can do better, especially with with AI and machine learning, right?
Mm.
So with these tools, we could input some data sets on some material structures, their crystalline lattice structures, and how strong they are, different variables as well, like their biocompatibility, their UV tolerance, all these different properties, and then you can kind of let the machine learning algorithm give you some other forms that potentially could be better materials. They could be stronger. They could be more resistant to UV. So they're using these at universities right now, including the University of Utah, to develop super hard materials. And I think that this sort of technology will take over the industry, and hopefully more institutes will start using this, and we'll start seeing a huge material innovation
Yeah.
era.
Yeah, that's awesome. And when we get into the future scenarios, I definitely want to get your thoughts on what are some of the ultimate materials that we may create or discover in our
Yeah,
lifetime. But let's hold off on that for the future scenarios. I do want to ask about a couple other filters of how to view materials. So one of them is medical, and we've been putting stuff in our bodies to help with medical issues for thousands of years, but obviously we've made a lot of progress more recently. And so first, before we get into crazy new stuff like brain machine interfaces and how that all works, why is it that some hip replacements your body will reject and other types of materials used for hip replacements your body will accept? Like what's going on with certain materials being okay with being inside the body versus not being okay inside the body?
right. So biomaterials are kind of funny, right? We're kind of got away from the peg leg era or like wooden teeth, right?
Right.
So biocompatible materials, there's 4 ways that they could interact with you, just materials in general. One is they could hurt you, right? The other one is they could dissolve. 3 is your body can surround them with a protective layer,
Mm.
or they could bond with your living tissue. So with the titanium hip replacements and such, I think there could just been an alloy in it that certain people are allergic to, like a nickel.
Hmm.
Um, but that brings about an interesting question as well. Like the way that hip replacements have kind of evolved is that they're propelled by 510Ks, right? So that's a way for an implant to get passed by the FDA with limited oversight, just because it's as similar to
Oh,
the
this is where
previous
if it's
iteration.
similar to something else that was approved, they can basically
Yeah,
fast track it.
yeah, they
Right.
can fast track it, so it's not really they haven't done their due diligence on the actual biocompatibility of the material,
Hmm.
right?
Yeah.
So that's probably explains why some of these, prosthetics or implants react because they just haven't been tested.
Right. Right. Now,
But down to a material standpoint, it's probably something to do with the alloy or the way that your body reacts to the alloy.
right. Now, when we go further into things like, replacing your organs, where you can 3D print a heart. They've done this on a small scale. They haven't really figured out how to do it successfully. Like right now, you're
Yeah,
still way better off getting like a cow valve or a pig valve than something that was produced in a lab. But it does seem quite possible that we could have artificial hearts that are just as good as the real thing and don't need to be replaced like, every year or every 10 years. So I'm curious your thoughts on that and also on brain machine interfaces where, Elon Musk describes brain machine interfaces as like kicking a TV and somehow it works.
yeah,
It's like you're putting these like electron receptors just by your neurons and somehow your brain is able to figure out how to control those electron receptors. It's like incredible. So I'm curious to hear your thoughts on the more
BMIs.
more modern approaches to biological materials.
Yeah, so the 3D printing tissue question. It's interesting, right? There's a company in San Diego, I believe, called Organovo, which had this claim that they could, 3D print organs, and it's been like 20 years, right? It's just been incredibly difficult.
Hmm.
Um, but I'm starting to see, more and more research done with stem cells and some collagen scaffolds, right? So you build the organ or the tissue with a scaffold of collagen hydrogel, and then you implant stem cells, which
Hmm.
then kind of do what stem cells do and build the structure, right? So it's less that we can actually synthesize these and 3D print these. It's more that we have to let nature and biology do its own thing.
Right. And this actually brings me to another question I wanted to ask you, which is the
Yeah.
distinction between living materials and non-living materials. Because I've heard one material scientist say that the real difference from a material science perspective is that living materials are far more reactive, whereas non living materials aren't as reactive, but they can still have some passive reactions. So, for an example, if you take your hand and you put it over a hot stove, it's not just that your skin cells will be damaged. They'll also actively send a nerve signal to your brain to tell you, "Hey, take your hand away this hot stove, you idiot."
Yeah, yeah,
whereas if you just put like like a paper clip on a hot stove, yeah, it'll like bend and become softer, but it's not going to have any like that's a passive reaction. It's not going to actively react. So I'm curious to hear your thoughts on like, is there a real distinguishment between living and non-living, and also the question of like what role consciousness may have to play. Like,
yeah.
anyways, I'm
No,
curious to hear
actually,
your thoughts.
I was talking with somebody about this yesterday, and it's like what level of consciousness, like what's the lowest level of consciousness, right?
Hmm.
And I think it's probably at the atomic level, right? I think the definition of consciousness is the ability to react to your surroundings, right? And atoms do this, atoms do this with other, oxygen atoms, right? But as they get bigger and bigger and bigger into a human form, they have stronger responses to stimuli, right? If you're asking what level something alive at. I think that's probably a question for a biologist, right? At like a cellular level, you could say that maybe that's, the definition of life.
Yeah, I'm with you. I think it's kind of arbitrary to say that it just begins at some stage of complexity. It seems much
Mm,
more natural for it to just be an intrinsic property of
yeah.
the atomic and subatomic world that just
Mm,
arises and emerges along with so many other phenomena. But it's kind of amazing to think about the possibilities where if you construct from the atomic or even the subatomic level, just to think of what we might come up with, like the fact that humans arise from these same sort of structures. Like, I saw that humans are basically just made out of, what is it? Like, it's like carbon, hydrogen, nitrogen, oxygen, and some calcium. And that's like, and then,
pretty
God
simple.
breathes the breath of life into the clay figurine, and somehow you have a human being. I don't,
Yeah,
yeah.
no, we're very simple creatures, and we are, you know, based on the elements of the earth, right? That's how we propagated and how we emerged as a being, right? And that's, pretty incredible. Like if you think about, the whole universe, and somehow this DNA propagated in this one location on Earth, and it's somehow assembled itself to produce life and humans. And we're having this conversation right now.
It's absolutely mind blowing. My mind has been blown so many times this last week, like thinking about materials. So
Yeah.
there's just one other filter I want to go through, and then maybe we can move to some rapid fire questions. So one filter is space and space travel, space exploration. Obviously, we just had a massive milestone achieved, which is that SpaceX just launched a crewed mission into space, which is the
Yeah.
first crewed mission launched from America in more than a decade. It's also the first private company ever launched into space as a crewed mission, and it's the first ever like really modern crewed space flight where you have like digital touch screens and it actually feels like a modern spaceship. So I guess my question to you is, when you're a material scientist, what are you thinking about as far as what sort of materials are best to use for a spacecraft and
Hmm.
also for an astronaut's suit to protect them from radiation and why that's so important for astronauts? Like, what materials
Um,
are crucial for space travel?
well, for space travel in general, the problem is getting a bulk mass out of orbit to another planet or another, rock in the term of the moon. So we have to reduce weight. I think it's like if you're going to Mars, every 2.2 pounds is like $100,000,
Wow.
which is pretty incredible. So in the exterior of a spacecraft, it's probably going to stay pretty stagnant for the next foreseeable future, right? We have to trust these materials that we're putting people in and shooting them out in space. But like for the interior of a vessel, you could use some carbon fiber reinforced composites to slim down on waste or weight in general. Um, Also, you could use certain alloys of titanium for non-critical components. Um, so I think those are two big
Yeah.
ones that you'll start seeing the use of nanoparticles and graphene in the electronics, and also the metals in general. They make it so much stronger in terms of tensile strength, and they protect against electromagnetic radiation, cosmic radiation, thermal. If you're going into an atmosphere, you could kind of absorb some of this thermal load and distribute it.
Right. Because, yeah, I mean, our Earth's atmosphere absorbs 75% of the sun's radiation, but you don't have that protection if you're in space. And I've heard
No,
astronauts
no.
talk about how you actually see these like flashes in the back of your eye because there are atoms like hurling through space, hitting your optic nerve. And you think
It's
about
terrifying.
that, something moving at that speed literally goes through your spaceship, through that helmet of your of your spacesuit, and hits your optic nerve. So you can see that with enough of these like atoms like hurling through you and messing things up, it can really be damaging for an astronaut's body.
Hmm.
So yeah, I mean, I've heard that if we are to create a safe colony on Mars, we'll basically need to build it underground with lots of layer of concrete or just dirt or what or whatever, some sort of like real barrier. It's not like you're gonna have like
Yeah.
a beautiful geodesic dome where you can look out at the Earth through windows. Like that's not gonna happen unless there's some
No,
major innovation.
the best way to do it is find a big hole, dig it, and then plug it, right?
Yeah.
You kind of protect yourself with
Is
natural structures that are there.
Is it possible that we could discover some new material for spacesuits that would 100% block radiation, or is that like kind of seem far-fetched?
Well, I think that is a question for the AI, right? The
Mm,
AI integration with material science. Like we can actually develop materials that are specific for light and UV radiation and cosmic radiation, right? We just need to, kind of gather all this data and then interpret it that way.
yeah, that's a good point.
Yeah,
Awesome.
but for structures on Mars, yeah, that's an interesting question because, like, um, you need to have some resistance to cosmic radiation, the fluctuations of Mars' surface. So, like, maybe a composite polymer would be the best material to choose.
Yeah. And I have just one other question, then maybe we can get into the rapid fire. So, computing is obviously another really crucial area for predicting the future. And up until now, we've used copper in our transistors and our chips. But I've read that there's an issue where as we get smaller and smaller and smaller, the copper is going to corrode and have issues, and it's not going to function properly as a transistor. But if we use some other materials, like if we have a layer of graphene over the copper, then we could potentially have much smaller and just as effective computer chips. And then if we go one level deeper and rather than using electrons, we could use photons, which are smaller, which would allow us to go even smaller and even faster because at this point we're literally be moving at the speed of light. So
Yeah.
I guess how like bullish are you on that, and what sort of progress are you seeing? And if you had to make a prediction of, when we'll have like a functioning commercially available computer like that, what would you say?
I would say I'm kind of bearish on the whole photoelectronics. I think we're going to probably stick with electronics for as long as we can. I think the use of graphene in electronics will hopefully become a reality, right? If you could have almost no resistance to electrons, you would kind of be, moving in the direction of the speed of light,
Yeah,
right? And you could make electronics smaller and smaller, right? The size of transistors are getting smaller and smaller and smaller. So hopefully that graphene will be our golden ticket in that arena. But I think that the problem currently with graphene is the manufacturing, right?
right.
The scale of manufacturing right now is very difficult, especially if you're doing mechanical exfoliation, like if you're taking layer off by layer.
Right.
Um,
Well, I saw this TED talk where this one researcher was saying she had found a new method where you actually convert methane into graphene, which would be amazing because it's a one of the main pollutants. And if you
sure.
were, so you'd basically kill two birds with one stone by creating something that we very much need, which is graphene, and eliminating something that we would want to eliminate, which is methane. Um,
Yeah, the same goes for flash graphene. I don't know if like you're very familiar with that or read
no, I
anything
don't know
about it.
about it.
So flash graphene basically takes anything that's carbon bearing, like rubber tires or plastic bottles, PET bottles, um, and you heat them up to, I think it's 3,000 degrees Kelvin, and it turns them into turbostratic graphite, basically, like these misaligned layers of graphene, and they're easier to cleave off than if it was in like stacked forms, like
Hmm.
in graphite. And that would be amazing because you're basically turning garbage and stuff that is going to pollute the environment into a usable product, right?
Yeah. Yeah, it seems like so
So,
much of the future is just about making better use of the materials we have. Because one thing that's different from history is we actually pretty much know like what materials are on Earth and where they
mm,
are, at least in a broad sense. So
yeah,
it's kind of like when you're in the part of the video game where you've already uncovered the whole map. Like there's no uncharted map left, but now you still have the challenges of, you know, winning the whole map.
yeah, for sure. I think probably the areas that we don't really have any idea about are oceans, like what's on the ocean floor,
Mm.
and that's kind of the next territory to pursue. Um, but yeah, you're right. We kind of have a good idea of the areas that are easily accessible that we can extract resources from. But I still think what I'm bullish on is graphene.
Hmm.
I think that's the golden ticket. I think more research dollars are spent on graphene than any other material for good reasons, right? If we look at some of the resources on Earth that are scarce, like number one, drinkable water,
Mm.
right? And the way that we can make more drinkable water is by desalination, which um, out here in Carlsbad, I think we have a big desalinating plant, which takes a lot of energy
Hmm.
to take salt water and make it drinkable.
Israel
Um,
too.
yeah, yeah. Any place that's coastal, right, has the chance to
I've heard
have a
they're
desal.
also considering using the moon to make water and also to make jet fuel.
Yeah, no, that's a good point. Yeah, so the same thing goes with building lighter aircrafts. If you could actually produce the fuel for the aircrafts um, on the moon or on Mars, you would save so much money
Right,
on
because the fuel's so
fuel weight.
heavy, to have to carry that
Yeah,
with you in a spaceship is super onerous.
yeah, and the law of diminishing return. The more that you bring up there, the less that I mean, it really makes sense because you're using more fuel to get out of the atmosphere with all that weight from the fuel,
Right,
right?
right. Yeah.
Yeah, so you could do that with kind of hydrolysis of the water that's on the moon, and then on Mars, you could find some of these water deposits, or you could do what's called a Sabatier reaction, which is with the carbon dioxide
Hmm.
that you would bring up from breathing, and a catalyst bed. I think it's nickel that they use,
Wow,
and
that's pretty
then
badass to like reuse your own carbon dioxide to make jet fuel. That's,
yeah, yeah, exactly.
that's
And
amazing. That reminds me of, have you ever seen the movie Waterworld? Where
no, I have.
like the opening scene is where he's like peeing into this like receptacle that converts it back into clean water because it's like the most
Oh yeah.
scarce resource in this water world because it's all like seawater. But
Oh, there was also another film with Robert Pattinson where it's a bunch of like these ex-cons that get shipped to like different planets, to
oh, I haven't seen
basically
that. That
they're,
sounds good.
yeah, and they're reusing their excrement to make
Right.
fertilizer and drinkable water. So they have like three tanks, one with like brown water, gray water, and then drinkable water, and they're all right next to each other. So it's kind of this like it's like an eerie look at
Yeah,
recycling.
yeah. Yeah.
But yeah, no. So with the Sabatier reaction, yeah, you produce methane and water. So that could be beneficial to look into. I think SpaceX has considered it as a viable option.
Nice.
And also, if you want to get into deep deep space mining, also
Oh yeah.
that could be a
Well, let's save that for the future scenarios. So let's take a quick break now and then do rapid fire and then future scenarios. All right. Are you ready for some rapid fire questions?
Let's go. Let's do it.
Okay, first one. What, in your view, is the single greatest threat to human civilization?
Single greatest threat to human civilization. Um, I would probably say climate change.
Will machines become smarter than the average person, i.e., will artificial general intelligence be achieved by 2050?
Yes.
Will consciousness emerge in machines once they've reached a sufficient level of complexity and intelligence?
Yes.
Do you support universal basic income? And how likely do you think it is that most jobs will become automated and will no longer need to be performed by humans?
I support universal basic income. I think within the next 5 years, like we'll see a large reduction in jobs, mainly from automation. Even with the in the manufacturing sectors, like that's going to be the biggest areas that are hit. Also with truck driving, stuff that can be replaced by autonomous vehicles, Uber, Lyft, things of that nature. So I think it's a great threat to our economy, but also it's inevitable.
Yeah, yeah, we're on the same page there. So this is relevant to, obviously right now the George Floyd protests and riots are breaking out across many cities throughout the US. So it's such a tough issue. There's the police brutality angle. Obviously, a lot of the rioting stuff is not something that is, we should really condone, but it's kind of understandable the level of anger that is being felt. So I'm just curious if you have thoughts on if these current riots and protests are a turning point, or if it is, in a more bearish perspective, maybe it's not a turning point, and we're going to see more and more of this type of stuff.
Hopefully, it's not going to continue. Hopefully, it is a turning point. I think the frustration and anger is understandable,
Hmm.
and you know, any life that's taken is wrong, right? We're all a part of the same consciousness, and we're all pretty much the same thing, right?
Yeah,
Um, so hopefully, people start understanding that you know everybody deserves equal rights and equal treatment. Um, and this is a turning point. Hopefully, for our generation, this will be our black swan event that we say, oh, we can look back on and say, okay, everything changed during the coronavirus pandemic. Not only the way that we look at viruses and epidemics and pandemics, but also social rights and civil liberties.
yeah, yeah. I'm with you 100%. Okay, what major breakthrough would you be most excited about us achieving in our lifetime? Could be
Um,
anything.
Anything? I would say quantum computing would be a big one, but I do really want to see a Mars colony. I
Yeah,
think that'd be a major achievement. Once we see like terraforming on Mars, I think that would be like the greatest experiment in all of mankind because that will enable us to say, oh, we can do the same thing with Earth, right? We could, if Earth started dying, we would know how to revitalize it.
right, right.
So it's
That's
kind of
great.
like a test planet.
What in your mind would be a better system for discovering new materials and just encouraging science and innovation?
Yeah, I think academia has been, the place to be in terms of discovering new materials, scientific innovation. But lately, it seems like it's patent driven, and there's a lot, wrong with that. I think as we start to revolutionize our economy and the way that we work, right, working remotely, um, we could start seeing more people doing scientific research on their own, right? If you were given the tools to do such, like the Materials Genome Initiative, you're able
Yeah.
to, do some of these calculations online, and it makes science more equitable for all. And if you had, a basic uh, income, right? You're given, a certain amount of money each month. You weren't as dependent to be doing research for a company or, a institute. You could do it for yourself,
Yeah,
right?
I love
So,
that.
so hopefully that's the direction that we go into in terms of science, but also, when great minds get together, you know, we get
That's great
some
too.
pretty great stuff. Yeah. So
Yeah.
I don't, you know, want academia to fail. I want it to
Right.
prevail, but
It's
also
more
I
just
think there
about
needs to be
having
some
as
competition.
yeah, having as many different viewpoints, sort of following their own curiosity, but also
Yeah.
collaborating at higher levels. Okay, last question for the rapid fire series. What in your mind is the meaning of life?
I think there is no objective meaning to life. I think that we all need to find it for ourselves. And I think, namely, what kind of propagates in a lot of people's view of the meaning of life is helping others. So, giving back to humanity in a beneficial way would be the general meaning of life. Um, but some people just like having a good time and, enjoying the small things in life, and that's just as important. So, I think giving giving forward to the next generation would be the common meaning of life.
Yeah, yeah, I feel you. I used to say that the meaning of life to me was happiness and different levels of happiness, but now I feel like it's more accurate to say that the meaning of life is to emerge, like to continually become a better version. Sort of like what you just said. It's like leaving the world a little bit better than you found it for the next generation so we can continue to progress and emerge and have, higher quality of life for us and for all earthlings.
Mhm.
Now I want to get into the future scenarios. What is the worst case scenario for the future of materials science?
Worst case scenario.
The worst case scenario could be that corporations start using AI and quantum computing to model and synthesize new materials specifically in order to patent them and restrict the free market.
Mm,
They set the course for new technological advancements, what's best for their shareholders, and perhaps we overuse these tools and we kind of forget how to make advancements on our own,
mm,
right? We stray away from the human intellect and creativity. Um, Also, we keep exploiting non-renewable resources to make products that are not biodegradable,
mm-hmm.
and we do not come up with any way to recycle them into usable products or some things like graphene.
Yeah. Yeah, I had a similar worst case where, we could obviously run out of certain materials, like you mentioned water, but there are other valuable materials where even if we don't run out of it on a global level, certain countries could run out of it, and then that could lead to conflict. There's already been
Yeah,
wars fought over oil. We could in the future see wars fought over food or
vaccines.
yeah. So that's one worst case for me. Another one I'm curious to get your thoughts on is Nick Bostrom has this concept of pulling the black ball from the urn of invention, where,
Hmm.
like, what if just through discovery we found some material that for one reason or another caused the end of human civilization? Like, it just
Wow.
infinitely propagates itself, or it, like, I don't know, like, I mean, obviously we haven't found a material like this, so it's very, we're sort of just putting our finger to the wind here, but it seems like there's a non-zero chance that there could be some material that we could discover, like like splitting a nuclear bomb. Like some scientists were worried that if we split the hydrogen atom, um,
We
it
kind of
could,
emanate.
yeah, it could light all the nitrogen in the sky on fire and we would literally blow up the whole planet. So who's to say there isn't some material or some way of treating materials that would have a similar effect?
I think that's a reasonable fear, but I don't think it's really a material that we would synthesize. Namely, I think what I'm most afraid of is a sort of bacteria or a virus, like a biological material that does propagate itself naturally, right?
Yeah, yeah.
That is more what I'm worried about
Well, yeah,
currently.
and then there's the AI scenario of if a bad actor is controlling the AI, or if the AI just doesn't have the proper utility function, maybe it'll optimize by, turning the whole world into paper clips in one example, or,
Yes.
there's all those examples of it's kind of like how that saying where, all families that are happy in the same way, but all families that are unhappy are unhappy in their own unique way. It's like
Yeah.
there really is only one like best case scenario, and there's so many potential bad
Worst
scenarios.
case. Yeah.
Um, okay, cool. Let's move on to the best case scenario.
Best case scenario.
All right. My best case scenario is that AI and machine learning become used for material development to rapidly solve problems, right? If we run out of a material, we can run to the rescue and kind of produce more of it or understand how to produce more of it in terms of like drinking water. Hopefully we'll solve that issue pretty fast with some of these graphene nanotube meshes and filters. We get away from this Edisonian trial and error method in the research and development so that we could start producing some of these innovative materials quicker and faster. Um, and hopefully we can start using these to also reduce our carbon footprint. Um, Also, we could start using biofabrication to produce some products that don't need to be plastic, right? Like packaging foam or some household items like chairs or um, things that can be compostable. Um, and I think graphene is our future in terms of conductors. Um, so we start producing graphene on a large scale and start using it in everything as soon as possible.
Yeah. Yeah, I was looking into what some of the like ideal far future inventions would be if we had our ideal materials, and one is a space elevator.
Oh
So,
yeah, with graphene.
which
Yeah,
be yeah, potentially we could do it with graphene where I've heard that we might need to actually construct it in space and then like put it into Earth
tether
from
it down.
yeah, yeah, tether it down. But the amazing thing there is that then you could basically like, launch into space without having to use up all that fuel, and it'd just be a lot easier to go from here to this ISS and whatnot. So that would be awesome to see a space elevator in our lifetime. I mean, so cool. Also,
Yeah, it'd be a lot more reasonable than projecting ourselves out into outer space with an explosion, right?
right, right. Yeah, it's like what if every time you had to go up to the top of the skyscraper where you work, you had to like put a rocket on and like zoom yourself rather than just taking like an
It's
elevator or
ridiculous.
the stairs.
Yeah, for sure, for
Um,
sure. And also, it's good for construction, right? And also, we need lighter materials if electric vehicles are going to be our future,
yeah,
right? Different composites that are stronger. Hopefully, graphene can do that for us, or batteries that um, can hold more electricity. And hopefully, graphene can do that for us if it's as easy to produce it as flash graphene, right?
yeah. If we are in that sort of future where materials are super light, super strong, then it almost seems like you would only ever need to buy like three chairs your whole life. Like you have like
Right.
one really good table, a few really good chairs, like and I kind of feel like this trend has already been ongoing, where our parents really valued like fine china and like porcelain and like, oh, we only bring out these dishes for like special holidays. Whereas every millennial and Gen Z like doesn't care at all. They're like, I just want practical things around my
Practical
house so
thing.
that I don't have like just all of these things that I'm tied to anytime I move apartments. Like you want a more minimalist lifestyle. So I could imagine a future where everyone really just has super high quality stuff, only of what they need. So there's not a lot of waste. And
Mm.
what the waste there is recycled in an intelligent way.
Yeah.
Environmental friendly materials, like we already talked about, buildings that convert methane into graphene, biodegradable plastics, drug discovery. You mentioned that, if we're ever are in need of new materials, we could basically just calculate what's needed and materialize them. If we could do that
Mm.
with pharmaceuticals, that would obviously be phenomenal. Like right now with the coronavirus, imagine if not only could we create a vaccine for the coronavirus, but every time the coronavirus adapted into be a new type of virus, we could then just create a new vaccine for that. I mean, that would
Yeah.
be incredible.
Well,
Uh,
currently, I think some companies are doing DNA sequencing of certain viruses, but yeah, it takes them longer than quantum would. If you could do it instantaneously, yeah, you would get somewhere for sure.
well, and you mentioned quantum. One material scientist I was reading said that the um, the holy grail of material science would be a superconductor that functions at room temperature. So you could have a
Yeah,
quantum computer that just you can use in your normal room like we're using now with our classical computers.
yeah, that's a little bit far off, I think, because most superconductors only superconduct at super low temperatures, right? Um, but maybe you could find some of these materials with quantum computing at super low temperatures, right? So you need that low temperature superconductor to kind of materialize the room temperature
Oh, I
superconductor.
see. Right. So we might be a ways off from that. Um,
Yeah.
and then I have this like vision of the future that I've been thinking about for a while, which is really what we're moving in is the direction of being a god. Like you can materialize anything essentially out of thin air, like from a subatomic atomic level. So just imagine if you're in the year 2100, you're walking through an open field and you can just using your brain machine interface will something into existence like, oh, I would really love a helicopter right now, and then a helicopter just materializes from like nano 3D printers into this field, and then you can fly in it, and your digital Bitcoin bank account would get detracted for whatever the cost of those materials
Whatever
are,
processing,
but you
yeah,
can
processing
basically
speed.
just go around and create whatever you want. Very much like if you're in a video game where you can just like, place like different buildings and stuff here and there. And, there's obviously the concern of like income inequality. Like, yeah, maybe there are some billionaires or trillionaires who can do that, but the vast majority of people will still be like scraping by to just get enough like water and food and stuff. So ideally, we'd be in a scenario where more people, hopefully it's a much better situation for everyone in the future, not just for some.
Yeah.
Let's move and bring it home with the most likely scenario. So, how do you think material science is most likely to develop in the next, let's say, 10 years?
Most likely scenario.
I think that we probably will continue to produce non-biodegradable plastics until we have a crisis. Um, I think that we'll use Edisonian trial and error for as long as it remains beneficial to do so. So I don't think AI or machine learning will become as ubiquitous until some, forerunners in the industry make it so. Um, yeah, I
And
think.
do you see, like, is the U.S. falling behind like China in material science world, or are we pretty much on the same page? Like, I'm just curious on an international basis if you see any trends.
I see China producing more materials, and when you produce more, you kind of understand the manufacturing methods. You get better and better and better. So in that field, I think they got us pegged.
Right.
Their manufacturing techniques are just getting more and more efficient, and they'll start to automate them, and we'll be
Yeah.
behind for
And
sure.
most graphene is from China, right? That's where it's sourced, I
The
believe.
graphite,
Or the graphite,
graphite,
yeah.
the graphite specifically, yeah, I think it's from Southeast Asia. But again, we could find other ways to produce it
Right.
if that was ever an issue. But I'm sure they will give it to us for the time being.
Yeah, let's hope. Yeah, I would say for my most likely, I mean, the materials genome initiative that you sent me is super fascinating. I think that is probably going to be one of the biggest trends in the future is just the notion of it's not like trial and error mixing random stuff together. You're actually calculating what is likely to be the material you're looking for based on the
Hmm.
qualities that you desire. So that's going to be huge. And then I guess the final thing I'd say for most likely is that many of the pressing problems that humans face are a lack of materials. Like people fight over food, they fight over water, they fight over shelter so they can, be protected from the elements. So I hope, and what I actually believe is most likely, is that as material science develops, people will have better access to higher quality materials that last longer and allow people to just have a more robust preparedness against, all the slings and arrows of life. So I am bullish that material science will help to improve the quality of life for everyone, especially when you consider the environmental aspects of what's being developed. And of course, going to the stars and into outer space and creating better computers, like that stuff is all just so exciting. I'm just really excited to see what this field comes up with.
Yeah, I think you're right. As materials advance, so does the quality of our life, right? And going to space is fine and dandy, but for the main population, better materials is going to mean more. It's going to be more equitable for everybody, right?
Yeah,
People are going to have better things, and that's always good. Quality of life will go up.
We are all gathered here
that's
today
great.
to talk
Well,
about
thank you so much,
material
Drew,
scenarios
for
being
joining us.
Thank you.
This has
We're
been
going to
the
talk
future of
about what
materials
has
science.
happened,
Thank you
what
to
is
our
currently
listeners,
happening, and what will
and we'll see
inevitably
you next
happen.
time.
The past, the present, and the